Lesson 9.2 is covering functions. You're going to be completing function tables, something that we've actually done this year already when we graphed. A function is a relationship for every input. There is one output. Domain and range are two new terms that you'll hear in this chapter. Domain, what you need to remember about domain is domain deals with your x values. So when you set up your table, such as your x, y table, when we graph, x is talking about domain, and then your range is going to be dealing with your y values. You might also see it listed in the book f of x, meaning function of x. So y would be a function of x. So your range deals with your y values. The first thing that you're going to have to do is you're going to find f of 4. So if f of x equals x minus 8, you're going to find it when it is f of 4. So instead of using x, you'll be using 4. So basically what you're doing is substituting where x is. Well, x is here, so you're going to substitute what the new function is, and that would be 4 minus 8, and we get 4 minus 8 giving us negative 4. So f of 4 equals negative 4. 2. F of negative 6 if f of x equals 3x plus 4. So we're going to put in negative 6 in for x here. We have 3 times negative 6 is negative 18 plus 4. Negative 18 plus 4 is negative 14. In example 3, you're going to complete the function table for f of x equals 4x minus 1, then state the domain and range of the functions. Well, the domain, as stated before, domain is your x values. If we look over in our table here, here's x. These are our x values. So the domain is negative 3, negative 2, negative 1, 0, and 1. That's the domain. We are going to have to find the range by using this rule, 4x minus 1, just like this equation up above. In order to find that f of x, your output, also known as y, you're going to substitute in those values from the table. So the first one we have 4. In for x is negative 3 minus 1. Second one is 4 times negative 2 minus 1. 4 times negative 1 minus 1, and 4 times 0 minus 1, and 4 times 1 minus 1. Now we would go ahead and solve these. All I did is take those x values and input it into the rule. The first term, when you do your computation here, you get negative 13, followed by negative 9, negative 5, negative 1, and 3. Those are all your y values. So you put in for x, you get out for y, and y deals with your range. So your range is negative 13, negative 9, negative 5, negative 1, and 3. In example 4, we have functions with two variables. So we're given two variables. We'll use two variables to write an equation in words. Then we'll write out a function, and then we'll solve it. So example 4, parking fees. The price for parking at a city lot is $3 plus $2 per hour. Write a function using two variables to represent the price of parking for h hours. So the price of parking for h hours. Those are our two variables. So I'm going to say that P is going to represent price of parking, and H equals the hours that we park. So the next thing that we need to go ahead and do is go ahead and solve out, write a function for the price for parking. So we need to then determine how much it would cost to park for 2 hours. That's what our solving is going to do. So the function to write this out, your parking cost, P, equals, if we look back up into the problem up here. It says in the first line, the price for parking at a city lot is $3 plus $2 per hour. So price for parking, P, equals a $3 charge plus $2 per hour. So, and you can put the dollar signs there, but not necessary. So looking at the equation here, or the function here, we have P equals 3 plus 2H. Next is we're going to actually have to go ahead and solve here, and we need to solve for 2 hours. If we park for 2 hours, we're going to figure out what it costs us to park. So I would go ahead and right below my function, I'm going to go ahead and write it out. P equals 3 plus 2. In for H is 2, as stated above, 2 hours. So your price for parking is 3 plus 4, and your price, P, equals $7 to park. Same type of example here in example number 5. In example 5 says taxi, the price for a taxi ride is $5. So price for a taxi ride is $5 plus $20 per hour. Write a function using two variables to represent the price of riding a taxi for H hours. So again, I'll say P is price of taxi. H, as given above, represents hours. We need to go ahead and write a function. The function, then we need to determine how much it would cost to ride the taxi for 3 hours. So here's the price of our taxi, P. What you need to pay for your taxi, well, as stated above, you have a $5 charge. So $5 plus $20 per hour. So we have $20 per H, and here's our two variables. We've used both. It says to use two variables. So there's our function. Once you have your function, you need to go ahead and solve what they mention above. Above it says determine how much it would cost for a 3-hour taxi ride. So here we go. The price equals, there's that initial $5 charge, plus $20 per hour. An hour is 3, as stated above. Your price equals 5 plus 60 here, and the price would be, if you had the taxi for 3 hours, would be $65. This will conclude 9.2 functions.